going to see about the decision tree, first of all. Now, what is a decision tree exactly means to us? So, decision tree, we can say it's a part of forecasting. Now, what is a forecasting then? Forecasting is a something we can say with nothing but we are predicting future. Okay, so let's say I have a historical data. That data can be anything. Okay, now by using that historical data, I want to predict what will be the future, right? So for that, what is required? First of all, historical data is required, and by using that historical data, we will build a model on the data. Simple example which I can take is, let's say I'm working in a manufacturing company. My company is having its own product. Okay, so I just want to know the growth of sales of that product in the future, right? So let's say if I'm purchasing some raw material, right? So after that purchasing of the raw material, what I'm doing is a manufacturing, right? After manufacturing, what I'm doing is I'm giving that product to the supplier. From supplier, it is going to the retailer, and from the retailer, it's going to the customer. So this is entire supply chain management, right? So now where analytics can help me? So analytics can help you in end-to-end process. Let's say to know from at what time I should purchase my raw material. Because yes, I can predict that. Let's say I have raw material data, historical data from the dealers from where I'm taking my raw material. Okay, if I feel some dealers are not providing me a good material, or their material is costly, right? So I can find out from whom I can take a raw material, because if I'm getting my raw material very costly, ultimately what happens? My product cost will be more. And you know nowadays there is lots of competition in the market, and customer is not waiting for anybody, because you have lots of customer is having lots of options, right? If I'm not happy with any of the product, I can switch to another company, I can switch to another brand for a particular product, right? So from taking raw material to find out correct dealer and the right time to purchase, because that time I can purchase that on very cost effective manner. Then if I'm sending that, let's say if I'm manufacturing that product by using the raw material, right? So if I'm into the food industry, so what is important? I should know how much I can keep as an inventory. And in inventory also, how much I can keep as a raw material, how much I can keep as ready in progress, work in progress, right? And how much I can keep as a finished goods. Because demand is very uncertain. Right now, if I have that much demand, I'll not be confirmed that in the next few months or in the next few years, my demand will be certain or my demand will be constant. No, demand is very much changing thing, right? Demand is not a constant thing, right? So now what I can do by using analytics, if I am able to predict demand by analyzing historical demand, by analyzing historical data, right? If I'm able to predict the demand for next few years, yeah, next few months, what will happen? It will very much helping me, because if I know the demand, I should know then how if I able to predict how much I can keep as an inventory, how much I can keep as in a work in progress thing, and how much I can keep as a finished goods, right? Okay, because if I'm putting lots of inventory and my demand is not that much, what is happening? I'm blocking companies' capital in that. without of no reason, because demand is not that much. Still, I'm keeping that much as an inventory. And in the food industry, what will happen? You can't reuse your material, right? It is having an expiry date. And if I have limited finished goods and still my demand is more, again I'm in loss, because I'll be having opportunity loss, because my demand is huge, but I'm not ready to face that demand. So this is one example of analytics. I've taken supply chain management analytics, right? So what is the today's agenda? We'll see the decision tree. First of all, we see what is predictive analysis, why it is important. As I discussed right now, what is the predictive analysis and why it is important. Second thing, about decision tree. What is a decision tree? Third thing, two most popular decision tree algorithm. Now, why algorithm? Because when you are working with the tool, currently I have lots of tools in the market. I have R. You must have heard about this, right? R, SAS, W, Hadoop, Python. Yeah. So what all those are? Those are the tools which helps me to do data analysis. Because earlier we all were using Excel, but right now we are not using Excel, because Excel not give me that perfect analysis, first of all, and the second, you can't deal with the big data with the help of Excel, because Excel has its own limitations. You can't go with that with Excel. So what I can do, I can have all these options. I can go with any of these tools in the market, right? And all are the tools. Those are not the programming language. So if I am a non-technical person, I don't know any programming language and I've never done in my life. It's still fine, because you are using tool. So tool is nothing but which are having very less programming language, programming content, and more of it's of calculation based, mathematical based, right? That's why by using a tool, I can build algorithm who can directly give me an answer. Okay, so then why decision tree is required? On which circumstances or on which problem I can use a decision tree? Decision tree is one of the techniques which is required to solve a problem. Okay. Decision tree terms, how decision tree works, examples, advantage of decision tree, and point. So this all comes under decision tree. We'll see that. Now decision tree. Now, what is the predictive analytics first? It's a branch of advanced analytics. So when you see statistical technique, see, data science or analytics is called as end-to-end solution. How end-to-end solution? I have a data, right? That data, let's say my company is having some problem. How I can find out the solution? By collecting the data of my company, right? When I have a data, I convert that data into the standard data set. Why? This is called as data cleaning. Now, why this is important? Because my data can have lots of missing values. Means values are not available for that particular thing, right? Then my data is having some of the outliers. Means what? Some of the values which are completely different from all other values. It's called as outliers. So why you have outliers? Because that can be considered as a human error. Let's say I'm taking readings of my machine. So if I'm manually entering that reading, I can note it down some reading wrong, mistake. Yeah. Okay, so that is called as I require data cleaning from that. Then after data cleaning, what I'm doing is I'm converting my data set into standard data set by using any of the two. Because the data which you get, it's a big data. Means what? Very huge data, right? Then what I'm doing, I'm selecting business problem which is a suitable for my data. Let's say the techniques which are available in the market. Either I can go with a linear regression. Those are the techniques which I'm naming. Those are the modeling techniques and those we are using for forecasting. So either I can go with a linear regression, I can go with a logistic regression, depends on my problem. I can go with a decision tree, and if I just want to do the classification of my data, I'll use clustering. And then the output which I get, okay, after running the statistical technique, I'm getting my output in a statistical format, right? So I can't represent such an output in the front of everybody because nobody will understand that output unless and until you have statistical background or you have that background, right? So what I'm doing, my aim is to convert that output into layman language. Layman language, so everybody can understand that. Okay? So make a prediction about unknown future events. So I don't know what will be the future values. Let's say I explain you what will be the future demand. Currently I don't know, but I can find out that by using the technique, right? Then it uses many techniques like data mining, as I explained right now, to clean your data, to convert your data into the standard data set. So if your data is in raw format, what you are doing, you are converting your data into the standard format called as data mining. Then statistics, obviously if it is analytics, you require statistics. It starts from descriptive statistics, very basic statistics. Modeling, you are doing modeling. Let's say I'm building a model and I want to do a forecasting. Yeah. Now, machine learning and artificial intelligence is a part of advanced analytics. Okay? Decision tree is a part of machine learning in predictive analysis. So basically, what I want to say is why we go for a decision tree. Because decision tree gives me the output in a visual way. So if I am a non-statistical person, I don't know what is the statistical output. I don't know what is the linear regression. I don't know what is the logistic regression. So instead of doing all this modeling part, what I'll do is I'll run decision tree. So when I run a decision tree, I get my output in very of the picture format. So if I'm getting my output in a picture format, I'm able to analyze that, being a non-technical person. Okay. So for a decision tree, I'll give you one simple example. Decision tree we are using for a classification as well. So there are two kinds of decision tree. One we use for a classification and one we use for a prediction. Okay. So now, let's say I am a bank. Okay. So today I got 100 applications for loan. Certainly, I'm not giving loans to everybody, right? I'm not giving, right? So out of that 100 applications, to whom I can give a loan? So what I'll do? I'll categorize the applications. So my first condition is of age. Let's say factor of age. Person whose age is greater than 40 and person whose age is less than 40. Now the conditions is different. It's vary from bank to bank. Now why I'm doing this? Now whose age is less than 40 has more chance to get a loan. Why? Because in India we consider 58 as the age of retirement. So at the age of 40 if I'm giving loan or whose age is more than 40, he has very less time to repay my loan, right? So that's why what I'm doing is I'm just classifying. So I get one branch whose age is greater than 40. I get another branch whose age less than 40. So I'm only focused on the applications whose age is less than 40. They have more chances to get the loan, right? Now after age, what is my next condition? Nature of their job. So again I'm making two. One, those who are government servant, and second, who are salaried and having own business. So now who is having which applications are having more chances? Government. Because we have that mentality, right? They are having their job is permanent basis. So again I get a two conditions, two branches, right? So age less than 40, government servant has more chance to get loan compared to other one. Now again I can put a condition as education. In education again I put as postgraduate, graduate, okay, then middle school level. So what I'm doing classification and classification, and at the end I just left with few of the applications which are satisfying all the conditions. So then I can use another thing is number of dependent person on them. Right. So if they have more than one person depend on them, so again I am making that. So it's my conditions which I am putting, right? The conditions which I feel important. So what I'm getting is a classification. And at the end, I just left with a bunch of people. So out of 100, I'm just left with 4 to 5 applications which are satisfying all the conditions. So I can blindly give them a loan, right? So this is called as decision tree. So this decision tree is nothing but classification kind of decision tree. But using this decision tree, I can predict, I can build an algorithm. Okay, if value is this, then they are applicable. If value is this, I can predict. Let's say if I get an application, I run algorithm on that, I directly get the status whether that person is applicable for loan or not. Right? So this is called algorithm which I used. So this is called a prediction. So you use a decision tree for a predictions as well as classification. Okay? So there are popular algorithms. Binary split. Now what binary split is doing? When your variable is a categorical kind of variable. Let's say I want to predict whether that person is eligible for a loan. So what will be my outcome? Either yes or no. So what I want to predict? Eligibility. And what kind of values I am having in that? Yes, no. So I have a historical data. Means let's say last 1000 applications who has appeared for the loan. And if they are got loan or not. So I have that data. By using that data, I have built a model, right? So what I have predicted, either yes or no. So this is called binary split. Now GD index is more of the probability. So those are all the popular algorithms which we use to find it out. Which is your predicted variable which you want to predict, right? And how? Okay. Now this is your decision tree. So as I told you earlier, you have two types. One is to classify and one is to predict. So which variable go to the classification? Mostly which are categorical. You have classifications in that. And to predict, if your variable is a continuous, let's say I want to predict sales of my company and I just want to know on which factor sales is depend upon. So sales will be your numeric value. You can have monthly sales of your product, whichever is your product, right? So when your variable is a continuous, response means study variable, what you want to study, what you want to predict. Okay, so we can say linear relationship between predictors and response. Now why linear relationship? I'm becoming more technical now. When your data is a numeric data, that will not have more variation in that data. Okay, I'm taking an example of blood pressure. If I'm having a data of blood pressure, I don't have more fluctuations in that. My data is almost having same range of values. You don't have extreme values in that. You will have, but it's very rare cases. Normal 90% of the data is having normal values because it is having range, no? Even height, weight, salary. It's always having a very, it's not having extreme values. 90% of your data is a normal data. So in statistics, we have a term, it's called as linear data. Linear data means what? If I plot my data, okay, I am able to fit straight line to 90% of the data. Depends, 60 to 90% of the data. Means what? I'm getting all the values on straight line. This is a technique called linear regression. If I'm getting a straight line, what I'm able to predict, right? So this is called a linear relationship. Means those variables are linearly related with each other. How you come to know that? When you plot the data, that's required. Now non-linear relationship, predictors and response. Means what? When your data is a categorical data, you have repetitions of same values, right? If my data is a binary, what kind of values I'm having? 1, 0, yes, no, only two kinds of values. Then if it is a multi or more than two categories, then also you have repetitions of same kind of value. So when you plot such a type of data, you are not able to fit straight line to those values. If you have 0, 1, just 1, 1, 1 and 0, 0, 0. You not get all the points on one single straight line. Not possible. You get maximum 2 points on one straight line. Okay? So this is a diagram of a decision tree. You have first condition, then you are getting branches. Okay? So right hand are the conditions which are always. The right hand branch which are satisfying the condition and left hand which are not satisfying the condition. So this is one example. age is less than 30. My first condition is age is less than 30. Yes, it's a lot of pizzas. No, exercise in the morning. Means what? If your age is not less than 30, means what? Greater than 30? Because I'm saying strictly less than 30. So you are at least 30 or greater than 30, right? So if you are greater than 30, you are very particular about your exercise and all. Okay? So how I come to know that? By running the algorithm. So my first condition is called as root node. Means first condition. Then condition check. So whatever I'm getting, so I'm getting always branches, right? It's a lot of pizza, yes. Then you are unfit because it's not healthy, and if you are no, then you're fit. So ultimately, what your outcome is the same. No, I just want to predict whether you're fit or not. Okay. So in exercise in the morning, what I'm checking, yes, fit, no, you're unfit. So all the outcome, what I'm looking for a fit person. Okay. So how decision tree works? We are checking over here entropy. Now this is the formula, okay, which we are using for a decision tree. But we use this formula when we are doing manually, when I'm using pen and paper. If I'm using a tool like RSAS, I'm directly going for an algorithm, right? So entropy is called as Shannon entropy. Means what? How much information you are taking. Or in a layman language, I can say that maximum probability. Let's say if I toss a coin, okay, what will be my outcome? Either head or tail. I don't know what I will get. But if I study last 50 cases, okay, and I write down my outcomes, and I find out that maximum time I'm getting head by studying last 50. So it's not it's not like that ki my results are always same like your result. Your result will be different. Whatever analysis I am doing is based on my data. What my data is telling me. Right? So from last 50 cases, if I find out I'm getting maximum head. So what is the maximum probability? I'm getting head. So what is my entropy? Head. So last 100 cases if I'm reading, and I come to know that persons whose age is greater than 40 are not that much applicable for loan. That's why I put my first condition, whether your age is less than 40 or greater than 40. So my data, see, analytics is always depends on your data. If you change your data, your analytics will be different. Whatever analysis I'm getting is based on my data. So it's not necessary your analysis and my analysis will go same. No, it's not required. Okay?
So one interesting thing about Shannon is Shannon is the guy who has invented this algorithm.
Yes.
And the entropy is just name of confusion of people he has put the entropy.
Yeah. So
so
entropy, what we say is the measure of the amount of uncertainty or randomness in the data. So my outcome will always be random.
Yeah, and it's actually the thing is that when you have a raw data and then quantifying or actually when you have a raw data, you need to extract the logical outcome from that, because when you have, that is the major thing I think when we are doing decision making, and that algorithm does. So when you have a raw data, extract some words on that, and just check how much frequent it occurs, and
Yes.
from that you can choose the note of tree.
Yes. So from the last 50 case studies, if I come to know that I'm getting head,
Yeah.
so that will be my entropy because that's my maximum time offered output. Information gain. Now, what is the information gain? It measures the relative change in the entropy with respect to an independent variable. So as I told you, data changes, entropy will change. Let's say if I'm getting maximum 100 maximum time head, that's not necessary everybody should get head. You can get tail as well because my outcome is totally random. So information gain is what? If you are changing your data, your entropy is changing. So change in entropy is nothing but information gain. Okay. Now this is the example. It's very general example because to cover a decision tree, it's not easy in just half an hour because decision tree is very vast topic, right? So here we have an example that consider a piece of data that collected over 14 days. So what is my outcome? Whether we have played golf on that day or not. So how I'm going to decide that? Based on weather condition, right? So I have 14 days. On a day 1, outlook is sunny, temperature is hot, humidity is high, and wind weak. So I have not played golf on that. So maximum time when you get yes, what is your outlook? What is your temperature? What is your humidity? And what is your wind? So if I'm interested, what will be my entropy? No or yes? If my entropy is no, means most of the time I have not played golf. So why? Then I'll check the conditions. Yes, yes, yes. So I'll put a condition on outlook, sunny, overcast, rain. Right? In that again, temperature, hot, mild, cool. Right? And then at the end, yes or no, whether you played golf or not. So how we'll start? This is a very basic step we have given. Create a root node for the tree. Root node means what is your first condition always. If all examples are positive, means positive. If everything you are getting yes, 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 means a positive. You have played golf. If else if all examples are negative, written this node as a negative. Then you will calculate entropy, everything. So this we'll do with the help of our algorithm, which we have already developed. How we have developed the algorithm? Based on some historical cases, based on some historical conditions. Okay? So those are the formulas which we are using. So my first condition, as I told you, is outlook. Sunny, overcast, wet. So where yes, if your outlook is overcast. Yes means what? You have played golf on that day. Because your entropy is maximum yes for overcast. Now what is a pawning? This is nothing but called as the cleaning part, we can say. It involves removing the branches that make use of features having low performance. So when I use this model for the predictions, the conditions which are no, I'll not put for that. Let's say now if I want to play a golf, what I'll check first? Outlook. So if my outlook is overcast, I'll go and play golf. Or next time if I get a data, let's say if I'm getting a loan applications, I directly check the conditions where your age is greater than 40, yes. Business conditions are satisfied, yes. This person is eligible for loan. This is called pawning. So the negative, you are not taking ahead. Negative thing, you are not taking ahead. So the conditions which are not means the conditions which are not considering to be applicable for loan, I'm not taking those conditions ahead. So in linear regression, if the variables are not making impact on your dependent variable, you will not put that variable in your model. Means let's say if I want to forecast sales of my company, I want to improve sales of my company. And based on historical data, if I find out that advertising is important, customer feedback is important, okay, then location of my company doesn't matter. So what is important? I'll take that only forward. What is not important? I'm not looking for that, right? So what are the advantages of decision tree? They are fast. Means you get your solution very fast if you have an algorithm. Robust, follows methodology which is easy to understand, because when you get output, it's of very pictorial format. Can handle both numerical and categorical data. So if you have a categorical data, it will help you to do classification. Okay. Required little effort from users for a data preparation. Yeah. So when you are going from for an algorithm, your data should be standard data. It should not having a raw means like missing values, outliers, right? Non-linear relationship parameters do not affect tree performance. Non-linear means what? Categorical data. That data is not considered as a linear.